Hello, everyone. Welcome to the technical review for Rural KG. I'm Xiaoming Guo. Currently, I'm the technical lead for the Rural KG project, and I'm also serving as a postdoctor at the University of Alabama AI Center, working with Dr. Jackie Gong. Our Rural KG project belongs to the whole Proto-OKN project supported by NSF. The main idea of a rural KG knowledge graph is to linking and integrate multiple heterogeneous federal data sets. Today, I would like to introduce the rural KG from the following aspect. First, the data sources. We would like to introduce where and how can we get the data serving as a source of our knowledge. Then we will introduce the structurization and the semantic enrich. This is a key components in our data initialization phase. And then we will introduce our knowledge graph construction pipeline, in which the retrieve then reason part is a core mechanism of our work. Then I will introduce the reasoning process to demonstrate how can we utilize our rural KG to make the knowledge reasoning based on our own RAG pipeline. Finally, I will introduce the evaluation method. In the evaluation method, we have a well-organized question set, not only on the corpus and knowledge retrieval, but also the numeric data query and the insights and conclusion delivery. We are using the federal data sets over data sources. We consider federal data sets is well organized and of course has the highest quality. Using federal data sets is a little bit different, just because not only the lexical or text-based document provided, the key property of a federal data sets is the tabular data sets itself, like CSV, TSV file. The size may be huge. There are two types of data sets used in our rural KG. First, we consider it's like core data sets with from the organizations like CDC, SAMHSA, FBI. We highlighted the NSDOH in the table as shown in the slides. We use this as a starting point data sets because we think it's comprehensive and well organized. Along with the core data sets, we also incorporated auxiliary data sets, which covers topics like FIPS code, geolocation code, demographic information, rural county name code, and so on. The rural county name code is a standard published by the government to describe the development level of each county. It has multiple versions. In the 2013 version, there are like 0 to 9 levels. The level 1 to 3 are metropolitan and urban area, and the number which is larger than 4 you can consider is rural areas. After determining this data set, we can use NSDOH as an example to describe the knowledge flow for our knowledge graph making pipeline. We consider the pipeline as a knowledge transition. We use a DIKW pyramid to describe this process. From bottom to the upper layer, you can see that the knowledge is from the data. After introducing the structure, the data is turned into information. After introducing expertise and experience, we convert the information into knowledge. But NSDOH is followed a similar way. The respondents or ordinary people make behavior in their daily life, and all the activities related to substance and mental health is observed or collected by the federal dataset designer, and then they convert the unformatted data into a well-organized formatted data and publish the NSDOH datasets. They publish the delimited datasets, which in the CSV or TSV format, and a companion codebook to introduce how to interpret data. We should emphasize the concept of variable in this knowledge representation included in the federal data sets. The variable is you can consider simply as a head of a column in the data sets. But in fact, in the federal data sets, it's not just a header of a column. It's a backbone of the data units as a metric or indicator of the survey or report. And also across multiple data sets, the concepts and the variables may be shared. There are tiny or noise differences maybe, but we can use a middleware or other mechanism to linking or merging the variables across the data sets to facilitate the future cross-domain reasoning. And based on the published NSDA data set, we extract the ontology and knowledge graph from a codebook in which the variables are also incorporated so that we construct the anchor point or bridging between the data sets and the knowledge graph. We finished the hybrid and semi-automated pipeline to construct the knowledge graph from the federal data sets. The semi-automated pipeline starts from the evaluation phase. Based on 3 criteria we published, we select and locate the most valuable data sets. For each data set, documentation, we consider 3 parts as the highest priority and should be considered the main components of the document processing. First is the table of contents. We consider the table of contents generated by the federal experts represent top-level concepts in that domain. Second, the preface. We consider the preface part includes the backgrounds and domain knowledge for the domain analysis. And then the variable section, which is the core components of the federal data sets, serving as the basic data units. Although all this kind of information has been organized in a table-like or structure-like way, PDF, which is common types adopted by federal data sets, is not a formatted database. So we introduce a structurization phase in this pipeline. All the valuable information resides in the PDF are extracted and output in a formatted file, say CSV or TSV. Based on the processed formatted file, we extract the entity, predicates, relationship, and use a retrieval and reasoning mechanism to construct the final knowledge graph. And also, we have to emphasize that at each of the steps, an expert review is necessary. We found that even minimal expert review can significantly improve the performance. Here is a variable structurization process. We still use the NSDH codebook page as an example. You can see that on the top right corner, this is an example of NSDH variable page. All the variable codes, description, and answer options are organized in a table-like way. We use a multimodality model to extract the codes, description, and answer options, and output all this information into a CSV list, as shown on the bottom of this page. All the question code content are from the codebook or the data sets, but the long description is generated by LLM. This refers to another mechanism we mentioned, is semantic enrich. As we are using a large language model to process all the information, we need to ensure that we can use semantic similarity to locate the expected variables easily. So standardization and enrichment mechanism incorporate for the entity like other topic appear in the codebook. We standardize its meaning and naming based on its related variables, as substance use pattern and behaviors. And then as we have retrieved the contextual information during the process, we use large language model to enrich the meaning of the terms as a paragraph showing on the right-hand side of the standardized term. By using this enriched description, we can conduct embedding and locate it easily, even based on a single word locating in the future RAG pipeline. After extract the entity and relation from the formatted CSV and TSV enriched list, we can get a large number of fragmented entity and relationships. So a merging mechanism is necessary. The details of our retrieve and reasoning pipeline is shown on this page. For each candidate incoming entity, we embed them into vectors and retrieve the most similar or relevant top K candidates entities from our vector store, and then retrieve the raw description and use large language model to make the decision whether we should merge, subclass, create new, or ignore the candidates. And then we reorganize the knowledge graph structure, deepen the structure, or maintain the as it is. By finishing this in an iterative way, we will expand the knowledge graph and generate the final version. After generating the knowledge graph, we will use it to regulate our RAG pipeline. We consider regulation as starting every query by locating the expected entities. 3 queries are incorporated in our system, like service query, knowledge query, and the data query. We put the service query and knowledge query together because they all focus on the lexical or corpus information retrieval. We still categorize the incoming services, extract the entities, and find out the most relevant entities in our knowledge graph, and conduct the page path retrieval to find the most relevant information for the reasoning. For data reasoning, it's a little bit different after locating the variables, which serve the column header in the data sets. We generate a SQL statement and expression or cipher statement to retrieve a real number for the following information retrieval and the answer generating. By using this way, not only the lexical or corpus dataset, but also the tubular datasets are included in our reasoning knowledge pipeline. We finish all the reasoning part on our self-built system. All the materials and the link of the system can be found on our OKN official webpage. For the incoming service query, we will visualize all the treatment providers or other resources on the map. For the knowledge query, we will show the results just in the chatbot window. For all the queries, the logs histories are demonstrated on the lower left bottom panel. You can see the located entities, the generate dependence expression, all the intermediate results are showing in the lower right panel to support the accountability of our system. We also provide the KG management and visualization page. From this page, you can see the dynamic of our knowledge graph along the iterations of our procedure. You can see that in the first round, the top level concepts are extracted. The intermediate concepts will be extracted in the second round, and more knowledges entities are incorporated along with the iteration of the procedure. Finally, evaluation. As mentioned before, we incorporated 3 types of the questions in our evaluation process: the surveys, knowledge, and data. And also we set out the principle of our evaluation is that we do not only deliver the data itself, we also would like to deliver insights and a conclusion. Here is the question design. For the first question, provide me all the treatment providers within 10 miles. You can consider this is a knowledge and data delivery question with a calculation process. But for the ones rendered by the blue color, you can see we try to deliver some insights or conclusion related to the social determinants discovery. For finishing this insight deliverables, we usually generated SQL statement or appended expression to retrieve the real number for each subqueries generated from the rephrase module, and then aggregate all materials like corpus reasoning result, number result together to generate a final conclusion. And all the results can be found on our website and the shared doc. The future version for our system is very clear. We would like to incorporate more federal data sets, and we also would like to enhance our interface design for linking with existing knowledge graph ontologies and the standardized taxonomies, such as common data elements by NIH. We also would like to hold more seminars or activities for education purpose across the Alabama and the Mississippi campus and the communities. Thank you.